Alright guys, now we are finally getting to go into our next type of coordinate system, which is polar coordinates. And before we start this lesson, in this unit really, there is a file on eCampus. It is Polar Coordinates Handout. It is a Word document. I highly recommend that you print this out. It kind of looks like this, and it's going to have kind of like your notes, like a note-taking guide really. A lot of these polar coordinates, again, it's just kind of, drawing these coordinate planes here are kind of tricky. It's nice if you have one already, so just figured you might as well have the whole set of notes while we're at it. So again, print that out first. You got to pause this, go ahead and do it, and when you have that, then we can kind of go from there. If not, at least have it out so you can see it. Try to fill it out as best you can, but those are going to be, it's going to really help you if you have it. Okay, so anyway, a couple of things. That's one of them, is going to be having that handout. Also, this is that one section. I don't think we've even used it this year. We're actually going to look in our textbook. We have a textbook for this class. So either you got one at the beginning of the year. You can also take pictures. I have the one in class that you can look at and use. It's only one copy, but you can get pictures out if you need to do that. But anyway, that's where we're at. We are in sections 9.1 through 9.4 in our textbook. So anyway, to start with, again, all this stuff should be, I believe it's all written for you already anyway, but just talk about what a polar coordinate is, and a lot of it just has to do with how we are discussing our directions. So again, all this stuff should be written down for you if you printed out the notes, note-taking guide or the handout. And again, one way, it just really has to go with directions here. So one way to give someone directions is, again, to tell them to go, in this case, 3 blocks east and 5 blocks south. And that's, again, just going east and west, so left or right, and then up or down. An example, this is obviously not the same numbers, but it's like if I'm saying going 2 blocks east, and in this case 3 blocks north, that's a rectangular coordinate system because it kind of goes with, it just kind of forms a bunch of right angles. You can make a rectangle out of it if you double those sides. And that is what we basically always use. The polar coordinate system is a little different, and again, talking about if you're giving someone directions, it's like just telling them to go a half mile in a certain direction, and you're just telling the direction, you're telling the distance, and go. It's actually a little bit faster to do it that way. Sometimes you need to tell somebody to go down certain streets and you need the rectangular system, but sometimes you just want, instead of only going left, right, up, or down, you just want to go straight at a particular angle, and that's going to be a little bit more efficient. And that's going to be polar coordinates and polar graphing, and it's going to be again like that second method I was just telling you about. And it's always each point that we have is determined, so each point is determined by a distance and an angle. So this is going to be a polar coordinate system, and we have 2 numbers that we're going to have in here. That's going to be this 3.6, and then it's going to be this angle. And that 3.6 represents the distance from 0, 0 to our point, and our angles obviously our angle. And the way this would be written, instead of using the 0.23, again, this is equivalent to that, the one I have here, but it's going to be r theta. So in this case, one particular scenario we can use for this, we would say 3.6 and then 56.31 degrees. So that's basically what polar coordinates are and what they look like, and you'll see it again. It's going to use some angles and some things that we've learned in the past, just applying them kind of in a new way. So a couple things about polar coordinates. This again should be things that you have and you can use to look at. Just kind of, we can, obviously just review, and we pulled some of this for our handout. But again, we're used to, as I said, using that rectangular coordinate system. That's that XY system that we're used to using. So that's going to be your rectangular coordinates. Also, this is sometimes called the Cartesian plane, the Cartesian coordinate system. And again, that's the one we're used to using. So now that we're not that we're going to go away from rectangular coordinates, you're still going to use them, but now we're going to talk again about in this unit polar coordinates, and it's based on, again, concentric circles about the origin, or again we can call that the pole. So the pole is the other name for the origin when we're dealing with polar coordinates. And as I just stated just a minute ago, those coordinates are listed as r comma theta, where r is the directed distance from the pole to the point, and theta is the angle measured counterclockwise. Key again on counterclockwise, just like on the unit circle, from the positive x-axis, or again as we call it, our polar axis. Our pole is our origin, and then we got our polar axis, like our x-axis. And again, that's just the differences between rectangular coordinates, or the Cartesian coordinate system, Cartesian plane, and our polar coordinate system. So to get started here, let's plot a couple points. This is what that that polar coordinate system looks like in terms of, as I said, it's a little bit harder to draw, but you can see your concentric circles, which is just a bunch of circles, one outside the other, and so on. They don't overlap, and those circles represent the distance. You can kind of see the distance based on the radius of those circles. So this first point, if I'm going to label, is 3,315. So one way you can do this is you can take this point at 3, and then we're going to go 315 degrees along this circle. So as long as you know that 315 degrees is, then you can find that angle. So again, 315 is going to be 270, and then you go 270 plus 45, and obviously we know how to add, but that's going to put us at this point right here, and we're at 315 degrees, and that is our point. Again, I would label that again 3,315. You can also just kind of like start at 1, and you can go 315 degrees and then go out to 3. It depends on, you can really go either way. I mean, it's going to get you there. So you can either go distance and direction, or direction and then distance. But either way is going to get you to your point, and there it is. Next one, you got your -2, 3 pi over 2. And same thing on this, is we can do this a couple different ways. But first off, obviously you want to know, how do you deal with that negative? So what you would do if you're going to start with a -2, instead of going right 2, we go left 2 on our polar axis, and that would put us here. But then we're going to go 3 pi over 2. Now what you have to make sure you understand is this angle, the angle itself is a positive angle, which means I'm still going in a counterclockwise direction. I'm just starting at this point. So that's going to basically be 270 degrees, which is going to put me right here. So that's one way you can get there. And again, that's you starting with your R value, your -2, and then doing your angle. Now the other way to do this, and again we're going to get to the same point, is we can instead go 3 pi over 2. I just start at 1 here. I'm going to go 3 pi over 2, which puts me here. But then I know that all we're going to do at this point is we know we're going to go to 2. I think I said this bad last time. I have that point at -3. So let me change that first. This is where we ended up last time. So you notice I'm here, but because I'm using that -2, instead of going in this direction, which I would normally be going because that's where my angle is, I'm going to go in the opposite direction, and that's going to put me obviously at that same point. So with all that being said, bam, there's your point. And again, whatever one makes more sense to you is the one you'll use. I'll show both ways again on C, but you'll notice my angle's negative on this one also. So again, I tend to start with the R value, but again, it just depends. Actually, I kind of like both. I don't really care. But anyway, if you're going to go -1 first, again, we're going to go to -1, and then you just have to pay attention to your angle for C. This is -pi over 4, which means we're going to go in a clockwise direction. So I'm going to go clockwise. Pi over 4 doesn't take me very far. I can try to zoom in here so you can see it. So as I said, I start at this point, and then all I'm going to do is go pi over 4 in a clockwise direction. So that's actually going to put me right there. Okay, so that's going to put me at this, obviously, 3 pi over 4. So you have your -1, and then you have your -pi over 4. The other way to get there is to go -pi over 4, starting from the positive axis here, and then I'm just going to go the opposite direction, I'm going to go negative 1 means instead of going in this direction, which I would normally do because that's where my terminal point ended, I just go really 180 degrees from that point to the other side. And again, it puts me at this same terminal point. So those are how you plot your points. Again, you can plot them in either direction, starting with the R value or your theta. Regardless, it doesn't matter, and get your points from there. And those are basically all the scenarios you can have. You can either have both values positive, one of them negative, or both negative. So anyway, as you may recognize, if you didn't recognize already, is that there actually are a lot of ways that you can label these points. I mean, I showed you one way, but I talked about, like, for example, this point right here. I said it's at 3 pi over 4. Well, you know, if you think about it, it might be easier for you to label this point as 1, 3 pi over 4. You got your distance of 1, which you can see, and that angle is 3 pi over 4 from the positive polar axis. And then if you see, oh yeah, well that would be way easier just to go that way. Well, again, there are multiple ways to label your angles. You can start here and maybe go clockwise. That would work as well. And just, you know, that's something you obviously want to understand, is there's more than one way to get to your point. So again, some of the points I have here, some examples of that. We have the red point, which is right here. You can't see that very well. I will kind of try to get these colors somewhat the same. So you got this red point right here that I have highlighted. You see it? You can see it now? Okay. So that one, again, I just labeled a few different ways you can do it. You can do it in degrees. You can do it in radians. Obviously, there's a simple way to do this and a hard way to do this, but 330 degrees is probably the simplest way. You see you're going out 3, and then your angle is going 30 degrees in a counterclockwise direction. Probably a fairly efficient way to do that. You can also say, you know, if I can do it in radians, or you can go like -3, so that'd be -3. So you go out here, and then it's going to go 210 degrees. And again, you're just going in a 210 degrees in a counterclockwise direction. Again, both of them are going to get you there either way. And you can look at all these other ones. Again, just study these if you want to see some more examples, because all of these are going to kind of show you how to label these points in multiple facets. So this is just a good study page for you. Understand you can go positive, negative angles, or radian or degree angles. All right, so I finally got some examples here. So what I want you trying to do for all of these is to try to label a couple points yourself. I'm going to throw a couple answers up there as well, and we can try to do a comparison. Again, if you need to study these a little bit more first, do that, and then give yourself a shot here. I'm going to pause the video, give you a chance. I mean, I'm pausing it because I'm just next screen. You'll see I'll have the answers pop up, but I want you to try to find these yourself as well. Alright, so here I am. I got these points here for you. The first one that I have, again, is at 5 pi over 3. Again, these are some answers you can kind of use to compare, see how you did. So, oops, don't want that color. So starting with, again, 5 pi over 3, I started with just good old 5, 60 degrees. I would be going out 5 and just going up 60 degrees. Put you right there. The next one is -5, -2 pi over 3. So I'd be saying going out here. And you want to go in a clockwise direction to get to 2 pi over 3, and that would put you at that point as well. And then you have 5 going out 5, and then -5 pi over 3 is clockwise, so that puts you around the long way. And again, all these are going to get you to that same point. The next one, you come over to -230. I went and plotted that point first. So again, you go -2, 30 degrees, put you right there. So we're going to go 2, 7 pi over 6. So 2, and then 7 pi over 6. Again, just over 180. So that's one option. You have 2, and I can go -5 pi over 6, which is just less than 180. And then -2, pi over 6. So -2, and we're going to go pi over 6. So that's actually should be positive pi over 6. I'll fix that real quick. There we go, because I'm going counterclockwise. So there's your 3 points that you could have had, some options for you. And there's obviously more, but those are just some examples of what you might have. Okay, so moving on here, the last little piece here is going to be talking about converting from polar to rectangular coordinates. And if you remember the vertex, the trig form for for vectors, this is going to be very familiar to you because it's kind of the same thing that we used before. If you remember, you have your, if you understand what you're doing when you're plotting these points here, if you're getting this point, again, you're just basically using this distance and this angle. So if we want to use the same formula we use when we talk about vectors, we can convert from polar to rectangular because we have those two components and we have the x and y components in a right triangle. We can basically look at it this way. Our x value right here, okay, this is going to be our x value. Now we can represent that x value as r times cosine theta, and the reason why is cosine theta is equal to x divided by r, which is going to be adjacent over hypotenuse. And if you look at this triangle here, the one I have on the right, here's theta, x is adjacent, and r is your hypotenuse. So those things match up. You can do the same thing with your y value. It's opposite over hypotenuse. So that's where these things come from. And that's how you're going to do a quick conversion from polar coordinates to rectangular coordinates. If you have it in terms of r theta, you just plug in for r and theta. Just plug r in for r, and theta in for theta, and you've now got an x value. You got to simplify it, but you got an x value. And the same thing with a y value. Converting from rectangular to polar just involves you doing some math going, obviously the other way. So if you have your x and y values, again looking up at this triangle, if you have your x and y values, to get the r value, you do Pythagorean theorem. X squared plus y squared equals r squared. So that's what's going to get you your r value. Yeah, I think I got to find r. And the next thing is to find theta. If I want to figure out what theta is, I know that tangent of theta equals y over x. So if I just did tangent inverse of both sides, we'd have theta equals tangent inverse of y over x. So that's how you can get your theta value. Again, you need polar coordinates, you need r, you need theta. And it's solving right triangles. So that's where those formulas are going to come from. And again, it's nice to know where they actually come from. Obviously, I'll review this even more in class, but just trying to give you that quick heads up, and that's how you're going to do your conversions. So this page is going to be very useful for that. Maybe a good screenshot right there would be awesome. Like I say, you have your handout as well. So here we're going to do some quick changes, and then we're basically all set. So I'll do A for both example 3 and 4. I'll have you try doing example B for both of them. So I'll do A first. I'm going to change from polar to rectangular coordinates. So again, the quick recap, you're going to go from polar to rectangular. Here's what we're doing. It's just the same from your vector units. And you can even draw the triangle if you want. It also can help. But it's just going to be r cos theta and r sin theta for your x and your y. So here our r value is 8 and our theta value is 30. So x equals r cosine theta, which in this case is 8 times the cosine of 30 degrees. So this would be 8, and then you'd have to just know, obviously your cosine value. So if you're in the unit circle right here, you're at 30 degrees, which is this point. That's going to be radical 3 over 2, 1/2. So this is going to be radical 3 over 2 in this case. So my x value, if those cancel out, is going to be 4 radical 3. So that's my x value. Do the same thing to find your y value, and that's going to be r sine theta, which is going to be 8 times the sine of 30, which is 8 times 1/2 now. We're just looking at the y value of that point. And I know that that's going to be 4. So your point is 4 radical 3, comma 4. So that's how you, again, quickly go from polar coordinates to rectangular coordinates. And to switch this up, example 4a, we're going to change from rectangular to polar. So again, right now we have our x and our y value. So remember, if your triangle, you want to find the radius, which is your r, which is your hypotenuse of your triangle. Remember, r is equal to the square root of x squared plus y squared. So it is equal to the square root of 16 plus 16, which is 32. Now you want to simplify this radical to get your r value. So that's going to be the square root of 16 times the square root of 2. So 4 square roots of 2. So that's your r value. Remember, when we plug this in, it's going to be r theta. So I got my r value. I need to find theta, however. And remember, theta, if you're thinking about this like a triangle, you got your 4 and your 4. By the way, this is 4 radical 2. You can kind of solve that triangle if you thought of it as a 45, 45, 90. You don't have to do Pythagorean theorem, but we got it anyway. But we're trying to find theta. Okay, and remember, theta is going to be found in this case by doing opposite over adjacent. I guess you can do opposite over hypotenuse since you have the hypotenuse, but just to keep it consistent, we'll just keep doing tangent inverse like we did with vectors. So I'm going to go tangent inverse of y over x, in this case 4 over 4. So that's just going to be tangent inverse of 1, which we should already know is 45 degrees. So this will give you your r and your theta. So 4 radical 2, 45 degrees. And that is your polar coordinates. So again, take a look at those, review those real quick if you need to review the formulas for it. But I want you to try B for example 3 and example 4. Alright, so here are your answers for B for both examples. First one, we have r cos theta and r sine theta. We just have to know what cosine of 5 pi over 3 is. And again, if you're at 5 pi over 3, you are on the unit circle at this point, right here. So those points are actually wrong, so let me fix them real quick. I'll pause the video and I'll fix it real fast. Anyway, that's better. So you got the right point, and when you get the right point, so you're at this point 1/2 negative radical 3 over 2, so I'm doing r cos theta and r sine theta. And once you get these points right here, know that cosine is your x value, so it's this 1/2. I'll highlight the values as I'm going through here. So that's the 1/2, whereas the sine value is going to be your negative radical 3 over 2. So that's where I'm kind of plugging these values in. So again, it's r times the cosine theta and r times the sine theta. We simplify them, and that's what's going to give you your point. So that's going to be converting to rectangular, converting to polar. Again, r is basically the Pythagorean theorem. So I just did a little bit of math here, just so you know, if you're aware. Negative 8 squared is 64 times radical 3 squared is 3. This guy right here is 64 times 3. So that's what I did to get the 192. That actually ends up being a perfect square, so we get r equals 16. And tangent inverse, these guys cancel out. You get tangent inverse of radical 3, and that is going to put you right at 60 degrees on the unit circle. So that gives you your r theta. So again, that's going to be some conversions. So assignment wise, here we go. I said we're going to finally use that gold book. It is the gold book. Anyway, if you're using that, it's page 538. It is 1 through 11 odds. We are going to try to put these all are all just plotting polar points. We can all put these on one grid to simplify things a little bit. We are going to use a polar graphing grid. I'll try to get that, I'll have one up for you on your campus. Or you can just draw your own. It doesn't matter. I mean, it's just drawing those circles. It is a little different, but it can be done. Anyway, you do that, and then do that on one grid, and then page 557, you'll see 1 through 23 odd. So go ahead and give that a shot, and I'll see you in class.